Happy New Year. Welcome to the January edition of Family Steam. I am Miss Jen, coming at you from the Kids Base main branch of the Gale Warden Library. Normally, you might have noticed someone is missing from Family Steam, and that is Miss Nikki. She is MIA. Could she be outside in the cold weather? Could her feet be frozen in a snow block somewhere? We don't know. We'll have to stay tuned to find out. But since we are talking about snow and cold, I thought this would be a great time in January to talk about ice and snow, which both come from water. That's right. So we are going to talk today about a couple of experiments you can try at home. And first, we're going to talk a little bit about the different states of water. So states meaning what form does it take? What form does the water take? So does anyone have any thoughts on that? You can put it in the chat. There's 3 states normally we think about when we talk about water in all of its forms. And what is water, first of all? Water is molecules. You might have heard of it as H2O. And what does that mean? It means 2 parts hydrogen, 1 part oxygen. And water is an essential thing to all life on Earth, us, animals, plants, our entire planet. So it's a critical resource. So when we talk about water, we're talking about 3 different possibilities or states that water can be in. The first is water. So if we have pure water, right, pure water, it's colorless. Here's some in this measuring cup right here, right? Colorless. Since I know this is water, it's safe to kind of smell. I'm going to use my 5 senses. I don't really smell anything. I smell the plastic a little bit, but I don't smell the water at all. So it's colorless, it's odorless, and tasteless, right? It's really important to drink water every day, and there are a lot of water in some of our foods, like our fruits and vegetables especially, but we're very fortunate here in the United States that we have access pretty much all the time to clean, safe drinking water in most areas. So you'll see a lot of water bottles around, both the plastic kind and the recyclable kind, and that is in its liquid form, right? So we've got liquid water. But what happens if it gets cold outside like we've had lately, because we are in winter in January? What happens is what? We get ice. That's right, ice or snow are different versions of precipitation in the colder weather. For example, anywhere from maybe late October, November, all the way into, for sure, December, January, February we expect it. Sometimes there's still some precipitation, snow in March for sure, sometimes April. So it really depends. And of course we know there's been a lot of different changes with climate and weather in the last decade and even more than that. So first form of H2O, or the first state of water is, or what type of form does it take, is liquid. You can see here, sloshing around, right? Oh, there's a drop that landed on the table. So there's liquid. Another form that it can take is ice or snow. And we've seen that a lot lately. So I don't know if you guys have played outside in the snow at all. We haven't had as much snow so far this year, knock on wood, as we have had in previous winters. Miss Nikki and I did a STEAM program recently talking about the snow games, and the average in the Chicago area the last several years is somewhere around 40 inches for the whole winter. But think about that. Miss Jen is about 60 inches, but it'd be taller than my waist if we put it all together. We're talking about a whole winter. So a whole yardstick, which is 36, plus a little bit more. That's how much snow we've been getting. But I don't know if any of you experienced this last weekend, a couple weekends ago. We had snow on the ground, right? Then it had warmed up during the day a little bit, and right in the evening, when it started to cool off, we had some humidity in the air, we had fog. But as the fog hit the ground was cold, it turned into a sheet of ice, because that's the solid form of water, right? So we have liquid form of H2O, The solid form is ice or water, and it was like a sheet of ice out there on people's driveways, in the roadways. We have to be very careful so we don't fall or get hurt in weather like that. So even though we had these weird kind of conditions where there was a little bit of fog, when it hit the ground and the temperature dropped pretty quickly, because once the sun goes down in the winter, even if it's nice out like today, it's kind of sunny and a little bit warmer, it's gonna get cold really quick. So it turned to ice, which that brings me to, we have water, liquid form, we have ice, solid form, and then I already alluded to or mentioned a couple minutes ago, the gas form. There's a gas form of water too. Do you guys know what it is? That's right, it's fog or steam or humidity. So solid water is like room temperature water, right? Or it could be colder or it can be warmer. There's a pretty wide range. When we talk about frozen water, which is ice, we are talking about 32 degrees Fahrenheit, 0 degrees Celsius, or below that, okay? Right around 32 is when it starts to freeze. So if it's 33, 34, maybe not. 31, 30, yes. 32 is that point where it starts to change from a liquid form to a solid form. And we're gonna talk about that today. But then you can also go the other direction. So if it has to get cold to turn to ice or snow, and the room temperature and warmer than that and a little cooler than that is liquid, what do we need to get the gas form, the precipitation form, the humidity form, the fog form? That's right, we need it to get really, really hot. So if you want gas, water as a gas, it has to be over 200 degrees, usually 212 degrees, which is very, very hot. It would burn you for sure. You have to be so careful, but Miss Jen before, when she's been cooking, has had something boiling on the stove, and if you accidentally reach over and there's steam coming out, then you could really get hurt. Doesn't have to be just touching something hot, because those steam vapors are 212 degrees, and we have to remember, our bodies are 98.6, right? So that's over twice as hot as we are, so that would definitely burn you if you did that. So 32 and below is the solid, right? It's snow and ice. If it's above 32, 33, and we go up quite a range now, we have the liquid form of water, H2O. But then if we get really high up, above 212 degrees, then we're gonna get a gas. And I warmed this in the microwave earlier. I'm gonna do a quick temperature on it. I'm using my digital, so it's quick. I don't think this is at 212. I can almost guarantee it because there's no steam. But I am curious because it is pretty warm still where it's at. So we'll see here. Microwave is a modern-ish invention that really helps us warm things quickly, and it agitates the water molecules and gets them going, and that makes it hotter. So, okay, we are at 122, it said. Now it says 114, it drops really quick. What is interesting though is I warmed this a little earlier, and I'm gonna come closer so you guys can see. There is some condensation or humidity on the sides of the measuring cup from when I warmed this earlier. So it came up and out as steam, and then it is clinging to the sides of the plastic. So let me get closer to show you. We'll see if you guys can see this. So right here, you can kind of see in the sides here, there is steam. So those molecules earlier got hot enough when I microwaved this that they turned to steam. So, and then as it cools down, this is our life cycle or the water cycle, right? It comes back down, the vapor will turn to moisture again, and it is clinging to the sides of the plastic. So when we're talking about the water life cycle, we're talking about precipitation comes down, let's say, in rain or snow. Let's use rain though as an example. Hits the ground, some of it soaks into the ground, we need it for our plants and trees and things, and stays liquid and perforates down through the water table or enters our freshwater lakes like Lake Michigan, which we live near. And then some of it though will stay toward the surface, and then if the day heats up, it gets warm enough on the surface, goes up into the clouds, right? And then if it gets cool enough again, it comes down as precipitation. It's just a cycle that goes over and over and over again. So let's talk about a couple of experiments. The first one we're gonna try to do is with, both of them are related to water and ice because we are in January, like Miss Jen said, and it's a good time of year to work with those things. So I have put some water bottles in the freezer and I'm trying to catch them at the point where they don't freeze yet. They're right on that edge. Remember I told you guys between 32 and 33 degrees? So I'm gonna pause this. We're gonna go check on the water bottles and see how they're doing. So I'll be right back. Okay guys, so far after about 45 minutes, the water bottles are not cold enough yet to have the reaction that I'm hoping they're gonna have. So this is really interesting. I've read 2 hours to 2 hours and 15 minutes, but I'm gonna be honest, I've already been trying this a few times, right? Because we're doing experiments, this is science. You try variables, you try different things, you experiment, you change or adapt based on what you're seeing. And for me and the water bottles I've been using, 2 hours, 15 minutes is way too long. So now that means I'm choosing the 45 minutes, but now I'm checking it about every 15 minutes after that. So we'll check on it periodically. But all I took for your supplies, just so you know, is a standard water bottle. You do want to use either distilled water in a bottle or purified drinking water, because if there's debris or sediment or things in it, or even things we can't see with the naked eye, it can make it more difficult for the experiment to work. And then that's it. You just need the water bottle. You need to get it to the right temperature. It's really a timing thing. We want to catch it right when it wants to freeze and hasn't yet. And then access to a freezer. So there's different things you can do. You can put a bunch in at once, like if you had access to it, like 4 bottles, and like start them all at the hour mark, and then go from there, right? And try one, wait like another 10 or 15 minutes, you know what I'm saying? And just try different variables to see what happens. You can choose to add watercolor, food coloring to it or not, and just see. But a couple other things about what we're trying to obtain, which is ice, right? When we were talking about the water cycle earlier, I said the vapor goes up in the air, and what'll happen is in the sky, in the air, we have clouds, right, which are precipitation, but also like just in the earth, there's constantly things floating in the air, things we can see and not see, for example, dust. So sometimes the water particles will attach to dust, which makes them a little bit bigger, because sometimes you can see stuff with the naked eye, right, with your plain eyes, and sometimes you can't. And as it goes up and hits the sky and attaches to these things and becomes bigger, if it's really cold, like we have in Illinois in January, it'll come down, if it's cold enough, in the form of snow or ice or sleet. If it's too warm, say 35, 40 degrees, definitely 50 degrees, it's gonna come down as rain, both types of precipitation. Have you guys ever noticed though too that there's different types of snow? So yes, we're talking about snow being above 32 degrees Fahrenheit, but I'm sure you guys have realized this. Have you ever wanted, right? First time it snows, we're all excited. We want to go play outside in the snow. And maybe we want to make a snowman. And we go to do it, and it won't stay together. It just is like powder or dust or sand. It just falls apart. So it turns out the temperature, how close we are to freezing, and the type of humidity levels we have can have a big impact on snow. Excuse me, especially the type of snow you want to do things outside and play. So what can we do outside? We can sled, we can cross-country ski, we can downhill ski, we can snowshoe, we can build forts with our friends, we can make snowballs, there's all sorts of cool things. But you need the right type of snow for the activities. So if I want to build a snowman, or to do some snowballs or a snow fort, I need what we call like heavy, wet snow. And what's interesting about that is wet meaning closer to 32 degrees, right? The closer it is to 32, at that point it's barely snow or barely ice, right? We talked about that. If it's above 32, 33, 34, and get up from there, it's gonna be liquid. So it's this fine line, and sometimes, I don't know if you've helped your grown-ups clear snow before with like a shovel or a snow blower, probably little shovels out there. Some snow is very heavy, like an inch or two will feel, which is only about that much, very heavy and hard to shovel, and some of it feels very light. You could throw it and just blow everywhere. So the snow for building snowmen or snowballs or forts is you want that warmer temperature outside and it'd be almost precipitation, almost liquid, but it's not. It's still snow, and it's very heavy, and we call it packing snow. Now, sometimes, on the other hand, if you want to ski, downhill ski, for example, you want very light, powdery snow. And that's the colder it is, the more powdery and dry, the drier the air is, it holds less humidity. That's why inside our houses right now, this time of year with the heat on and there's less humidity in the air, our skin might feel drier. You might be using lotion. Miss Jen's got a Band-Aid because her finger's all dried out. So there's less humidity. The colder it gets, the drier it gets. And that snow is like I said, like sand or powder. But that's what skiers really like. And then I don't know if you guys have ever noticed, maybe you walk to your bus stop, maybe you walk a pet, maybe you travel around some. When you check out a spot over and over again and you haven't cleared the snow away and you step down on it, when we condense snow over and over again, or our body heat warms it, or anything warms it or causes it to be crushed and change form to liquid even a little bit, we might not even be able to tell very well with our eyes. Guess what? At night or later in the day, the temperature drops and that turns to ice. So sometimes, I know when we had that fog I told you that froze, it was like a shiny, freezing crust on top of everything. So you might have the snow underneath, and you guys have probably walked through snow like this, and then you're walking on it and it's like crunch, 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 because you are breaking through that hard layer of ice on top. So there's the powder, then there's, they call it crud when it gets kind of beat up some and you've walked through it, and then you get that crust on top is another one. And then you've got the packing snow that we talked about, which is great for playing outside if you want to do any kind of building or construction, snowmen, forts, things like that. Sledding, I think you can do either. I mean, if you've got that crust ice on top, it's going to be a lot faster for your sled if you're going downhill for sure. Definitely powder wouldn't be as good. Then the final one, which is the other way, right? So the drier it gets, the colder it gets, the more powdery, the warmer, the wetter. So what happens if we get just above that 32 degrees, it's going to turn from snow or ice to water basically again. Did you ever crush really warm? So some of the snow, if you work it too much or crush it too much, it turns to slush. Or have you ever seen for snow removal, sometimes they'll sprinkle something like salt down, and as it melts it a little bit, it turns to slush. Like the slushies you can buy and drink, but this is stuff on the ground that we wouldn't touch. But it's like this in-between, like partially water, partially snow or ice mixture in that slush. So there's even different types of snow. Okay, we're gonna take a break again and go check on our water bottles to see if we're getting closer to that tipping point between liquid and solid. We'll check in again in a little bit. Okay, steamer family, so we're starting with bottle of water, purified drinking water, and I'm going to add a little bit of blue food coloring so that we can see what happens, hopefully, if there's a reaction later better. Just a couple drops. And you can see the blues kind of heading to the bottom. So let me close that up. I'm going to shake it a little bit. So we've got blue water now, and now it's going to go in the freezer. They say for 2 hours, but this came actually cold out of a vending machine, so we're going to try, I'm going to check it at the maybe 45 minutes to 1 hour mark. So we'll check in again in a little bit. I'll keep you posted. Okay guys, so we have a blue, I just dyed the water blue to maybe make it easier to see, and a white one. They've been in the refrigerator for a while, I'm sorry, the freezer, for maybe 30 minutes. So we're gonna test it. I've heard it takes up to 2 hours, but it's really hard to get the exact timing. So the test is, you slam it down on the counter to see if any crystals form, which would be the solid form. So we're gonna try it. Nope. All right, let's try the other one. Okay, so no solid in either one, so I'm gonna put them back in the fridge and we'll try again in a little bit. Hi guys, okay, so we're trying the water bottle experiment, that's one. And then there's a couple things I can try with that, but here's another one Miss Nikki and I saw and she and I had talked about. And we're gonna try something with the water balloon. And it's just more of a fun kind of play outside thing. But I have a balloon and I'm gonna add a couple drops of food coloring. I'm gonna fill my balloon and I'll show you in a minute. Okay, so I'll be right back. Okay guys, I feel like I just diffused a bomb basically. This was intense. Wanted to have the water inside the water balloon have some color. So I took some food coloring and put it in. Then I got some water in there, but guess what? When you go to detach the water balloon, blue water was like whoosh, whoosh, spraying everywhere. So I know it's not very big, but it's a yellow balloon with some blue colored water inside. So I'm gonna leave it for a while and freeze it, and then I'll show you the result later. So we've got the first couple steps done. Okay, so we're gonna check in and see how this water to freezing looks. We have to get what? Below 32 degrees. So we'll check in a little bit. And like nice war wounds here. I got blue all over my hands. So all in the name of science. We'll see in a little bit. Okay, this is a couple other bottles of water. Let's try it. It looks liquidy. I don't know. No, unfortunately, it's just a mixture of water and ice. We'll try the blue one too, just to see. Nope. Still just, and you can see some ice is formed there. Okay guys, so we have the water balloon. I've put it in a Ziploc just in case it explodes or does anything weird. We don't want dyed blue water going everywhere. So I'm gonna put it in, we'll check it in a while. See if there's liquid to solid state occurring. Hi guys, so we've had quite a few misses with this experiment. And I did some research and it says it has to be 17 degrees Fahrenheit. So 2 hours was too long. Let's see where we're at temperature wise here though. I don't think this is at 17 degrees. So it's finding that perfect balance. We're at around, let's see, it keeps dropping, but we're really not close to 17. But this is interesting because we're at 33. Okay, so we're at 33 degrees. So I'm gonna put it in. It's been an hour and 5 minutes. I'm gonna do 10 more minutes and see. I'll keep you posted. Okay guys, let's do another update here. See where we're at. All right, 24 degrees. So getting there. Do 10 more minutes and see. And then my other update is the balloon. So feeling it, it's getting crunchy. So it still gives, it's squishing as you can see, but also there's slush inside. So we're getting there with that as well. Okay, check back in a little bit, 10 more minutes. All right guys, let's see again. I can't tell if it's freezing like it's supposed to. Is it possible that it finally worked? All right, so it kind of did. It's not solid, but there's a little liquid on top. But most of it turned to ice now. So let's see what the temperature's at. Oh my gosh, you guys. So I'm going to call this a partial success. It didn't freeze solid, but when I took it out, it was liquid. I slammed it. We've got a bunch of ice in there, and we're at 32 degrees, so the temperature's gone up. That is amazing. Let me put the lid back on. We can kind of see. So as you can see, it's fairly opaque. Now there's a little water at the top. So there's some water in there. But there's a bunch of ice too. And it did start at the top and spread down through the bottle. So we might try the experiment one more time, but this is about as close to success as we've gotten, and it's really close. It's not quite frozen solid, but the temperature's gone up, and when I hit the bottle like that, it caused a reaction. You can see how opaque it is throughout, right? It's not clear anymore. And when we first took it out of the fridge, it was clear and see-through. Amazing. That is a snap freeze. Okay guys, so we're back where you can see me instead of being behind the camera showing you those water bottles. Oh my gosh, that experiment, the snap freeze water bottle, took so many tries for Miss Jen to have some success. Just so you guys know, and I know you see a shortened version of the video, I think I tried it maybe 12, 14 times to get it right. So that tells me there's a lot of precision, but there's also variables. But let's talk about it briefly, and then we're gonna end with our water balloon. But how did that final water bottle go from liquid to solid quick? Where you all saw in the video, it like started at the top and drifted down and went from clear to opaque. So we talked about water cycles or water states, right? Solid, liquid, gas. How did we get from liquid water, which is supposed to freeze at 32 degrees, to not be freezing at below 32 and then suddenly turns solid and is 32? So what happens in this situation is, yes, water should freeze at 32 degrees. However, if the water's pure enough, and that's why they recommend purified bottled water or distilled water, there's a possibility, there's no particles, it needs a nucleus, it's called nucleation. The crystals need a little home base, a starting point. So if you have pure water and it's undisturbed, it sat very quietly in my drawer, it got colder and colder and colder and didn't start to freeze. I think in the video we saw it got down to maybe 24 degrees, 22 degrees, well below the 32. However, once it was cold enough and sat long enough, they're most likely that I couldn't easily see were a few ice crystals. And when I tapped that bottle on the counter, a couple of those crystals fell. There's the nucleus, there's the home base, and all the crystals made a huge chain and connected and started from the lid. That's why they usually start at the top, and you saw it went from top down. A couple of crystals fell, and then it started a chain reaction, and they all came down the bottle. So that is the snap freeze. Now again, in mine, there was maybe 75, 80% ice and a little bit of water left. I have seen videos where it's 100% ice. If you guys try it and have success, let me know. All it requires is a bottle of purified water, distilled water, and a lot of patience. I think the final time total for that bottle was 2 hours and 10 minutes, 2 hours, 15 minutes. So it takes time. But if you have any success, we'd love to see a photo or a small video. You can post it, or you can email me at kidspace@gailborden.info. Okay, final thing. This was much more obvious, We started with our water balloon, right? We love water balloons in the summer, but Miss Jen filled it with a little bit of food coloring and then filled it with water. It's kind of messy, by the way, especially when you add it's kind of a mess, be careful. And I had it in a Ziploc in my freezer because I didn't want this to accidentally explode or leak blue water all over. But we have definitely gone from the liquid to solid. Oh, but I just kind of popped it and it's falling apart a little bit. So maybe it's still slushy, we'll see. Ooh. Okay, so there's still a little bit of liquid in there, the blue liquid. So I'm not sure how long. It felt solid, but what I think happened is we had a solid outside and a liquid core. So when I cracked it, it was kind of like an egg because there's a lot of solid right here still. Let me see if I can get it open where we can see it. It's very dark blue too, which is interesting because you're just kind of experimenting with the food coloring. Okay, so I'm cutting it using scissors, so grown-ups, if you're watching this, you would want to help. Okay, basically it did freeze. Let me show you. But we have two pieces, kind of like I cracked an egg. So it's falling into pieces because there was a little bit of water remaining. It's a beautiful color. And see, even with the heat from my hands, it's melting a little bit. It's dripping down. But I think you guys get the idea. This was an unintentional explosion, kind of like the exploding pumpkins Miss Nikki and I expected with our October family steam. I hope you enjoyed the videos. So remember, with one water balloon, some water and maybe optional food coloring, and with one water bottle of purified water or distilled water and some patience and time, you guys can try these two projects at home. And like I said, please let me know if they turn out. Thanks so much, you guys. Happy New Year again. Stay warm. It's chilly out there. We'll see you soon.